Okay, so yes, so if you are measuring your share price, let's say every second, every minute, every hour, right? So you have data which changes with a time unit. The time unit can be seconds, can be minute, can be hour, can be 15 minutes window, right? So you have a constant time interval. Okay, so you have a constant time interval and your data changes with respect to that unit. Okay, so if you talk about share price or talk about revenue, right? Revenue, if you ask, what is your revenue, right? The company will ask, okay, what do you mean by what's your revenue? Okay, you tell me you're talking about daily revenue or monthly or weekly, right? Similarly, share price, if you talk about, we talk about, let's say, start of the day or closing of the day, right? Or every hour share price. Okay, so you have a number, it's a numerical data, but it changes, okay, with respect to time, right? So like demand or sales, okay? We spoke about stock price or visitors to a website, okay? How many visitors visit your website, okay? So you'll ask, okay, what do you mean? Okay, is it hourly or daily or weekly, right? So your data, okay, changes with respect to a constant amount of time, constant time interval. Okay, so the weight is different from your um, regular regression, means continuous data, right? So the weight is different is that the data is time dependent. Okay, if you are able to remove that time dependency from the data, okay, let's say you'll say, okay, I ignore the time dependency. For me, a stock price, daily opening price is number, okay, irrespective of the time as such. So if you are able to remove the time component from it, then it would behave like a regression problem because you want to predict the continuous value, isn't it? Continuous variable. So it becomes a linear a regression or what you call regression problem. Okay. But if you are not able to remove time component, right, then you cannot use regression. You have to use time series analysis. Okay, so along with increasing or decreasing trend, most time series have some form of seasonality trends. Okay, so so when you look at a time series data, okay, and when you dissect it, okay, there are 3, 4 components to it. So one component that you hear is called trend. Okay, so now if you look at your website visitor, let's say Amazon itself. Okay, if Amazon wants to look at the trend, okay, or let's say your Swiggy wants to see how many people are logging to their apps, right? So during, let's say, breakfast, lunch, or dinner, right? Maybe morning 8, 9 o'clock, or afternoon 1 o'clock, evening maybe 8, 9 o'clock. They'll have a higher, okay, they'll have a higher people visiting their website, correct? So that is called a, what do you call that? You call that seasonality, okay, or you call it trend, okay, or something else to it, okay. So there are, when you look at the data, okay, it will not show a single pattern, okay. So the pattern changes based on time of the day. Now see, when you talk about seasonality, okay, seasonality would repeat. Okay, so if you're saying that every morning 8 o'clock, okay, the number of visitors to the website is highest, so it should happen every day at 8 o'clock, right? And when you see every day at 8 o'clock it is higher, we call it as seasonality. Okay, so there is a difference between seasonality and not. Okay, so see, there could be a trend. Let's say there is a cricket match, right? And then suddenly your people ordering food increases. That is not a seasonality. Okay, seasonality means that every time, okay, it's a fixed pattern. You can expect it to increase or decrease at a certain point. Okay, that is called seasonality. Seasonality, okay, as season, right? When you say winter, summer, right? So your winter and summer will come at same time every year, isn't it? So that's why I call seasonality. Okay, So seasonality is when you see the pattern, okay, which does not change, okay, and every time you will see the same pattern, whether it is with respect to month, whether it's respect to day, whether it's respect to quarter, right? So so one trend that you will see in your data is the seasonality, and seasonality would change at a particular time only. Okay, so that's called seasonality. Then you have something called as trend. Now we'll say that, okay, people are ordering 5% more every year. So the increase of people ordering from Swiggy increases 5% every year or every month. How do you get that figure? Right? Now, people ordering per day itself is not constant, right? It changes. Morning it's high, maybe around 11, 12 o'clock it will be lowest, right? Then afternoon again it goes up. In the evening, 5 o'clock probably it will be lowest. Night, there's no visitor. Okay, maybe 12 o'clock, 11 o'clock, you'll have one or two people ordering in a locality. So you have the up and down curve, right? It's not a straight line that you can say, okay. So so trend talks about your overall trend, okay, over a period of time. Okay, so okay, daily if you take, the value changes, right? But on average, what is the daily sales? So you try to, okay, let me if I can draw the graph here. And see the whether talking about your daily or hourly changes for business to business. For Swiggy, it makes sense to track at an hourly basis. But let's say if Tata Motors is tracking its car sales, then it doesn't have to travel, measure at every day. For them, weekly trend is also okay, correct? So um, let's say you will hear that, let's say if this is your 7 a.m., right? Probably it will increase like this at 7. It'll increase up to 9, then starts decreasing. Then again, it increases. Afternoon, it starts decreasing. And it increases in the night. Okay. So let's say this is the trend for day 1. Right. Okay. This is your trend for day 1. Now, same trend you will see in day 2 also. Correct? That's why seasonality, right? So if it is 7 a.m. to, or maybe let's say this is 12 midnight to midnight, let's say. If this is midnight to midnight trend, then you will see exactly same pattern. I may not be able to draw exact same pattern. So what I'll do, I will copy and paste it here, right? This is what you expect, isn't it? Correct or not? You'll expect same pattern, right? On third day also, you'll expect same pattern. So your graph would look something like this, right? Now, if you look at this graph, okay, so what you see is seasonality. 7 a.m. is highest in both the cases, in all the 3 cases.
PJ, we can't see the graph.
You can't see the graph? Sorry. You guys are not looking at my screen, that means. Let me do it again. So I was saying that, okay. Okay, let's say this is your x-axis where you're tracking your time, right? So let's say if Swiggy wants to measure how many people are ordering their, at what time of the day, right? So I told you, right? So maybe car companies, okay, may not be interested at even daily level, right? They might look at weekly level, okay? Monday to Sunday, how many cars they sell. We talk about grocery stores, big bazaar, probably they'll be looking at um, daily sales. Okay, probably they're looking at afternoon, evening kind of. They might not look at every hour, but they might create a slot, right? See that lower segment that you create, right? It becomes more complex, isn't it? It's easier to look something at monthly level versus hourly level. But depending upon your businesses, okay, generally if you look at this quick service restaurant, right? Your what do you call it, like Chinese restaurants or this pizza chain, they track at every 15-minute level. For them, every 15 minute is one period of time, right? We remember a constant period of time. Okay. So maybe something like that for Swiggy. Swiggy might also look at every 15 minutes as a time. So if you talk about midnight, 12 o'clock, okay, there may be hardly any sales, right? Suddenly at 7 o'clock, it'll go up 7, 8, okay, 8. Then slowly it start decreasing, right? Around 11 o'clock, probably it will be lowest. Then again, it will start increasing during lunchtime, comes down. Again, then it will increase and comes down. And this is your midnight 12, right? So this is the pattern you will see on daily basis, right? Now, what I was saying is I can copy this graph, right? And I can paste it here for day 2 as well, right? I can paste it for day 3 as well. This is called seasonality, because same trend you will see every day, every month, every week, right? You talk about jacket sales, right? Or umbrella sales. So every year, okay, during rainy season, you will see the umbrella sales goes up. Okay, every year in winter season, your jacket sales goes up. So when you look at the data, you will see that every time December data is going up, right? That is called seasonality. Okay, that is called seasonality. Okay, so one aspect of looking at data, time series data, is looking at the seasonality. Okay, and seasonality, as I said, we will repeat every year at same time, every day at same time, every month at same time, every week at same time. Right? That is what you look at in seasonality. That's why we say seasonal. Okay. Okay. So you have something called as seasonal or seasonality, right? Seasonality. Okay. Now, trend, okay. Trend is the data that you look on average. So on average, let's say daily sale is this much. Okay. Now, second day, on average, daily sale might increase. Now, this data I copied and pasted. So obviously, you will see there's no increase here, right? It is same. So average, if you draw for the day, you will get same, right? So now if you draw this average for a period of time for 1 year, okay, every day for say one month, okay, or for 1 year, okay, you might see, okay, something like this, right? Now, if you see a line like this, like red line, that means, okay, your average sale for the day, okay, or for the week, for the month, okay. So don't worry about the unit of time, because every company will use different unit of time. So if you see, there's a trend that shows that there's an increase of demand, okay, on in Swiggy's case, let's say it is increasing the demand every day. So it is like X, okay, reference point, and it increases by 1%, increases. So every day your demand increases by 1% over last previous day. Every day your demand is increasing by 1% over previous day. That is the trend. Okay, trend can be stagnant. Okay, there's no increase in the trend. Trend can be decreasing. For example, if you talk about the greetings card, people buying greetings card, okay, obviously the trend is going down, right? So these days nobody buys paper-based greeting cards, right? So paper-based greeting cards, okay, it might witness a decreasing trend, right? So, or a business which is in a very early stage, they're acquiring, that they might see a increase in trend, right? So your trend will tell you the average value for day or for week or for month, and you can see this is called trend. So your time series data has seasonality, it has trend, and it will have error. Okay. Now, what is error? Error is sudden spike or sudden dip, okay, because of some reason. Okay, so there's a India Pakistan match, right? And India Pakistan match, okay, and people are started ordering, let's say, online. So you expect your seasonal trend to be here, but on that particular day, okay, so it is one of case, okay, there is no pattern to it, okay, because of this India-Pakistan match, you see there is a extra order that people did here. But if you remove it, it will be exactly like this. So when we do time series analysis, we'll be able to, remove trend from the data, remove seasonality, remove error. Error is your one-off case. Then sometimes we also talk about cycle. Sometimes we also talk about cycle. Okay, cycle is something like which repeats. Okay, overall. Okay, you might see a trend. Like generally, what we talk about economic situation, right? When we talk about economic situation. Okay, if I draw a line like this, let's say this is the data, and let's say this is zero GDP growth. So what do you see? Sometimes the economy is doing very good. It might do very good for 3 years, 4 years, 5 years. Then there will be a dip. Sometimes it might go into negative growth. Again, you will see. So this pattern is repeating. Okay. But we don't call it seasonality because we are not able to predict which year's maximum and which year is going to be dip. Right? Now, this pattern could take here 4 years. Okay. 4 years. Now, in this case, it could be 8 years or 6 years. Right? It can be just 3 years. So we know that there will be a situation where economy will be booming. There will be a situation where there will be a downturn. Okay. But we don't know the width or the length of this cycle. Will it be 5 years? Will it be 10 years? Right? Or will it be just 2 years? So we know, okay, at some point economy will be at peak and sometime it will go down, right? But we are not able to predict when, right? I mean, of course, you are not able to guess. Probably you'll have to predict using some parameters. That's what we do. That's what economists do, right? They look at different parameters and they know this will be a cyclical, okay? So there's a difference between cycle and a seasonal. Seasonal, you know the time of the day or time of the year, when it's be maximum, when it will be minimum. But cyclical, you don't know the time. You know that it'll go up and down, okay? But we don't know exactly when. So that is cycle. That is seasonality is fixed, okay? Trend is, of course, the overall trend. Error is, okay, one of case, okay? One of a case. Maybe there's a heavy rain in that area, and again there will be a increase in order, right? Or there is a holiday, okay, long weekend, so people will probably go out of town, so there will be a dip, right? It's not always about increasing, okay? You can see a dip also. You expected this, but then this is what you see. Okay, so this is again error, right? This is error. This is error. So time series data has 4 components: seasonality, trend, error, and cyclical. Okay, and when you are predicting, when you are analyzing, we have to look at all these things. Trend is easy to get. Seasonality is easy to get. But you need to break the data into trend and seasonality. I cannot take all these 4 and start predicting, isn't it? I have to take out trend separately. Okay, I have to take out seasonality separately. I have to take out error separately, right? I have to take out cycle separately and then predict each of these things separately, isn't it? So see, if Swiggy knows that at every day at 8 o'clock, okay, my order is going to be X. Every Saturday at 8 p.m., this is my order X. Now, if I know that, oh, there is a match and that, a cricket match, and it will add an error of X1, then I can predict easily. Okay, so if I'm able to break all these 3 components, then I know, okay, X1 is the extra order I receive generally when there's a match. Okay, or something happens and I get a decrease in order, right? So if you are able to dissect, only then you will be able to predict each component separately and put them together, right? If you are not able to break, then you will not be able to guess, because these things will not be exactly same like your regression or classification kind of situation, isn't it? So it has many components. That's why we treat it differently. We have, different algorithms to treat it. Make sense?
Yes, yes.
So we have a data set, okay, called air passenger. Let me show you. Okay. It's called air passenger. Okay. It here. It doesn't look like here. It's not here. Must be in data set then. Yeah, air passenger. So if you see this data, okay, we have months. So we have data by months. So this is the total number of passengers traveling by air. 1949, January 1949. So this is your year, this is your month. Total 112 passengers travel in the entire month. Okay. People, travel more than this every second these days, right? So this is 1949,
Yes.
January, total 112 passengers. Then February 118, March 132. And we have data till 1960, I think. Okay. 1960, 432 people passengers travel. So we will take this data and we'll try to predict for next 5 years, like, for from 60 to 65, how many people will travel and things like that. Okay. So let's get down to pie chart. And of course, I think this is not going to work. So probably we'll have to, look at our local data set, but that's okay. Let's go back. Okay. So we are talking about time series analysis, right? Time series forecasting. We call it forecasting. So we look at these, we look at the past data and then we predict for next period, right? You look at your trend. Let's say you want to talk about share market prediction. So you're looking at the trend for last, let's say 1 hour, okay, at every 5 minute interval or every 1 minute interval or every 2 minutes interval. Okay, so if you're looking at every 2 minute interval, you need data at every 2 minute interval, right? Okay, you should be able to capture the price movement at every 2 minutes, right? So you're looking at the 10. Okay, so now see here. If I'm trying to predict on annual growth, I need to have last at least 1 or 2 years of data, right? 2 years of data I need to have. Okay, if my prediction, if my data that I'm capturing is at a daily level and I want to predict at month, minute level or hourly level, I cannot do it. Okay. So if I have my data at hourly level, only then I can predict for hourly level. If I have data at a 5 minute interval, only then I can predict data for next 5 minutes interval. So what this time series forecasting techniques look at is the number of periods that you have. Okay. You might have 12 period. If you talk about monthly, you need to have at least, okay, 24 is better. Okay. I cannot be predicting for the end, at annual level with just 3 months of data. Correct? With 3 months of data, I can only predict for next 3 months. Okay. So there are, so that's why you have to keep in mind the data that you capture, the period, okay, in the past that you have to capture, okay, and then you use that data to predict for, okay, the future. Okay, so we'll go with that. One the main, okay, analysis that we generally do here is called ARIMA method. Okay, so we will be using, I'm going to talk about what is ARIMA method in some time. Okay, so this is called ARIMA method. So IMA, okay, they have different components, okay, and all the other algorithms that you see here, we'll talk about it towards the end. are different variations of ARIMA model. Okay. So what we'll do here, okay, first we will, of course, read the data, visualize the data, and we will see all the 4 things that we spoke about, right? Trend, seasonality, cycle, and error. We'll see all those things. Okay. Then we will break it into stationary analysis, we say. Stationary, okay, series. Stationary series is the data where we remove all these components. Okay, we remove trend separately, we remove seasonality separately, we remove error. See, error is something which we can't predict, isn't it? So you have to know about the error. But seasonality we can predict, trend we can predict, right? Error we have to remove it, and then we make prediction without error. Okay, because error is something that can happen anytime, right? So you need to understand about the error. You need to know, okay, the match there's an error. Okay, long weekend there will be an error, positive or negative error. But other things we'll be able to. So that's why we need to get a data, time series which is stationary without these components. So we'll need to create that. Okay, then we need to understand the optimal parameters. Okay, that will go into ARIMA model, right? Then you build the model, and finally you will predict the model, right? Predict for next future. Prediction means future only, right? So we'll say prediction, right? So these are the 5 steps we will do in our analysis. Okay. So, okay, let's look at it. Okay. I'm going to import pandas to read it. Import pandas as PD. Okay. And let's read the data. So I'm going to say air passengers equal to PD dot read CSV, and I'm going to read it. So let me put something here. Lake equal to D colon slash data set slash this get data. Let me keep it from here. So you have data sets. Get data set. Then air passengers. Okay, so we are able to get this data. Now here we'll see a link. Okay, now you want to visualize it, right? So let's use something called as Plotly. Okay, so Plotly is another library using which we can actually do the plot. So we have seen Seaborn and Matplotlib. Plotly is another. Okay, it's also what you call as interactive. In a way, you can actually see the data on Plotly. So we'll see how Plotly is used. So we'll use Plotly, and it has Express. Okay, Plotly Express. So we'll see how it is used. So I'm going to call import. Okay, Plotly. Okay, so I had to format my computer so you don't see it here. We need to go and install it, right? So where is my Python? My Python is here, right? So this is the script. I go to Python console, and I'm going to, okay, this is the one, right? Yeah, and I'm going to say pip install Plotly. Oops. Let's go to terminal. I think. It's working. I think it's working. It says it's already satisfied. Okay. Installing Plotly. Okay, so this error will go away, right? If it installs correctly, this error will go away. It's taking time to install. Basically, we are drawing a line graph. Okay, so we'll draw a line graph. Okay, and data we have is monthly level, so each point will be shown as a month, right? So you have year and you have month, right? Um, hmm. If it doesn't work, we can draw using matplotlib only. I want to show you plotly here. Terminal will work here. Yes. It says it's satisfied. Okay. Import. Let me run it. Okay. Okay, now it's not allowing me to run. Stop it here. Yeah, it's coming. So let me run it, right? You can't run it because this is running. Stop. Ah, you see this? It's building the libraries again. Yeah, so no error. Okay, so let's see the line plot here. So I'm going to do so plotly.express. Okay, so we need to use express and I say PE. Okay, now we'll use figure equal to PE dot line. Okay, and here we'll give this data set. So which is data set is air passenger, and what is the name of X? So we need to give X, what should be on X and what should be on Y, correct? We need to give X value and Y value, correct? So let me go and copy the name, column names of X and Y. So on X, you have that year and month, right? And on the Y, you will have the count. So let me go and see the column headers, okay? So if you look at the, so it's called month, okay? And passenger is called hash passenger. So X equal to month and this is hash passenger. Okay. Now I'm going to say big dot show. Okay. Let's see. Okay. So Plotly it's a web-based thing. Okay. So the output you will get will be on a browser. Okay. So see, this is the data. You see here, this is the data on month, and you can see, point your cursor, it tells you the value. That's why I say interactive. Okay, this is the interactive. Now, this is the data that we have plotted, simple data we plotted. Now, this has all the four things that we discussed. It has trend. Obviously, you can see the trend is increasing. You can see the seasonality, right? This graph is very similar, isn't it? So there's definitely some seasonality, like people travel mostly in a particular month, right? Then slowest at some point of the year. Okay, from 1947, I think, 1949 to 1960. Okay, and this is, it has trend. You can see the trend, okay, it's increasing. Seasonality also can see, okay, the plot is repeating. So there's a trend, the seasonality, of course, there will be some error, there will be some cycle also, probably here. So now we need to decompose this time series data. Okay, so error is also called as noise sometimes. Okay, so if I go back here, let me close it or let it be. We'll go back to our program. Okay, so next step. Okay, so this is step 1. Or this is your step 1 rather, right? Step 1, read the data. Then step 2 here is to visualize the data, right? The step 3 here is going to be decomposition, right? Decompose the data, okay? So decomposition into you have trend, seasonality, okay, and what did I say? Error, or it's also called as noise. Okay, error is also called noise. Okay, it's one-time effect. Okay, so this is what we need to do. So there is something called as additive decomposition, and there's something called as multiplicative decomposition. So in additive decomposition, we assume that the plot or the data that you see is multiplication of all these three things. Okay, is a multiplication. So it's okay. So it's a linear combination of above three factors. So you will end up getting something like your y, okay, y at t. That means every data, okay, not just entire data, every data. So y of t will be your trend of t, right? Plus your seasonality of t, okay, plus your error of t, right? So this is called additive decomposition. So the time series is a addition of all these three things. Second type of decomposition is called multiplicative decomposition. That means your time series, okay, is a product of, right, of three factors. So in this case, your yt will be, instead of adding, it could be, okay, so so data could be multiplication of all these things. Okay, so so when you look at this data, okay, when you look at the data and you see the data is, see, multiplication will will increase the data by a much larger value, right? So if you see the data is increasing by a larger value, then because we have to, this is assumption, okay, we have to make assumption, okay. You don't have any factor that will tell you okay, you know that it will tell you that the data is additive or multiplicative. We have to guess it. Okay, so if I take you to okay, here to Chrome, okay, and let's say we go to Google here, and I'll type time series plots, something like this. So you'll end up getting multiple plots. You can see, okay. So if you look at our plot, if you remember, it increases by a bigger margin. It goes like exponentially, right? So when you see this exponential growth, probably you know ours is a more of a multiplicative thing, right? Okay. So these are some of the time series data. Okay, if it doesn't increase, so this is what we are doing. Okay, so it increases by a larger value. There are some data which may not increase by a larger value. Okay, so it might increase little bit. So there probably it is a additive decomposition. So so data is sum of all these three things that we spoke about. So we will go back and we will assume that ours is a multiplicative decomposition. Okay, ours is a multiplicative decomposition. So we will try to break it into all these three components. So I'm going to say here, we need to use stats model. So from stats models dot time series analysis TCA dot seasonal. Okay, and we will import here seasonal decompose. So import seasonal decompose. Okay, so this will help us to break the seasonality from the data set. Then we will say here like decomposed equal to seasonal decompose. Okay, and we will provide here okay, so so your decomposed needs, okay, our data, okay, which is our air passenger, right? Okay, our air passenger, comma, and model we will use is your, we'll say multiplicative, okay, and then we will try to draw this decomposed dot plot. Okay, let's see this. Okay, so this gave us error because our month, okay, is not in date format. It is in string format. So before we run, okay, we have to convert the data, right? So, okay, so let's say we'll put here cleaning the data or something like that. Okay, now here we have to convert it into date. So how will we do that? So I'm going to say from date time, okay, import date time, from date time import date time, okay, and air passengers, right? Air passengers month, month, air passengers month equal to PD, okay, pandas dot, okay, you have two date time, okay. Now this is going to convert it into date time, okay. So I'm going to say date time. You can create a third column if you want, okay. You can give something at like month date or something like that, and you can convert into third column. I'm going to replace same column. I don't want to create a new column. Okay, and then I'm going to say air passengers dot set index. Okay, the index will put it as month itself. Okay, and then we'll say in place equal to true. So we want date month itself as index. Otherwise, it will create a new index 0, 1, 2, 3, 4. We don't want that. Instead, we want to we'll say, because this is unique, index will be unique, right? So index is like, just like you have column numbers, right? 0, 1, 2, 3 or column names. You know, by default, pandas will have numbers for column rows also. So for rows, it will add 0, 1, 2, 3, 4 automatically. I don't want to add 0, 1, 2, 3, 4. So if I have not written this, it would have added a third column for 0, 1, 2, 3, 4. Like you can think of index as a primary key of that table. So we are saying, don't create new index. So set index month itself. Okay, so set index month and in place equal to true. Okay. Now, if you look at this, okay, this is going to be your, hopefully this will convert into date type. Now to convert it, now we have to convert. Okay, so okay, so so this is date time. Now we'll convert this into time series. We are saying that this data, the passenger data, is time series. So I'm going to say TS. TS stands for time series equal to air passengers. Okay, and I'm going to say this is your, okay, converting to time series data. So we're just going to say TS. Okay, now how do you convert? You can, okay, so actually this is the step, right? So we will say TS log equal to, okay, NP. Now I think we have not imported NumPy. We have to import NumPy here. Import NumPy as NP. So NumPy dot, okay, NumPy dot log. Okay, we're going to convert into log value here. So this is your, okay, or you can directly use this, right? You can directly use this instead of creating into TS and then doing it. Okay. Then, okay. Now, we'll create a period, time period. Okay. So since it's a monthly data, we'll create a time period of 12 months rolling data. Okay. We'll create 12 months of rolling data. So we have something called as rolling. Okay. So pandas has something called as rolling, and we'll say that, okay, create a 12 months of rolling period. Okay. So creating rolling period, that means 12 months will be one set of data, then second set of data, then third set of data, like that. So we're creating sets of 12 months of set. Creating 12, okay, 12 months. Generally, see, when you have monthly data, you know, because every month will be different, isn't it? So you create 12 months of data. If you have a daily data, right? So if you have a daily data, okay, like say shopping, like grocery shopping or your restaurant, there you'll create a 7 days of rolling period, because like Mondays will behave like Mondays, right? Tuesday will behave like Tuesday. So we'll say, okay, Monday to Sunday is one set, okay? Whatever, like if your data starts from Wednesday, Wednesday to Tuesday, data starts from Saturday, Saturday to Friday. So we'll say first 7 days is a rolling period. So you will repeat that again and again, right? So the behavior generally, if you see, will be similar, right? If you're talking about months, so January will behave like January, isn't it? Feb will behave like Feb. Monday will behave like Monday. So we're creating that rolling period. We're saying these 12 months will be similar. So when you're looking for a pattern, right, seasonality pattern, you will look at data in these 12 months and the next 12 months, right? In daily, if you're creating 7 days as rolling period, then this 7 days data you will compare with next week's 7 days data. Okay. So, okay, how do we do that? We are saying moving average. Okay. We are saying something like moving average equal to our data that we have created dot rolling. It should come rolling, and then we say 12 months and find mean. We'll look, see, so in 12 months data will again vary, isn't it? But we are saying, okay, take the mean value, okay, so that you get a straight line, you know. Okay, now we will plot different graphs. Okay, so I'm going to say import matplotlib dot pyplot as plt, and here I'm going to say plt dot plot what? So first we will plot the graph itself. Okay, so ts log. Okay, then we'll say we'll have the moving average. So it'll give you the average. Okay, plt dot plot. Okay, moving average that we have calculated. Okay, and then it'll say plt dot show. Okay, now here when we are doing decomposition, right? So instead of taking entire air passengers, we can only take TS log. Okay, we'll see TS log here, but we'll come back and see this. Okay, we'll come back and see this. Okay, let's run it first. This is the, okay, I need to share my screen. This is the Plotly example, which we did yesterday. Okay, so this Plotly will come. Oh, what happened? And Plotly dot import matplotlib dot pyplot as plt. Okay, now let's run it. This should give us the all the components, right? Decomposed. Okay, now you see this. Okay, so this is the component. Okay, so first graph, okay, that you see is your, okay, this is the data. First part that you see is the actual data, okay, which we saw yesterday also. Now look at the trend. What it has done is it has broken down your the entire data into trend. So you see, trend is showing that it is increasing over the period of time. You see that? Okay. Can you see it? Have I shared it? Yes, I have shared it, right? So trend is increasing, and your seasonality, there's a seasonality pattern, right? So look at the seasonality pattern, exactly same pattern. And this is your error, residual error. So we have broken down it into your trend, seasonality, and we call them residual, you call them error, you call them uh, noise. Okay. That's the term that we use: noise, residual error. Okay, trend and seasonality. Okay, let's go back to our program. Okay, so there's one more. So now we are ready to run our model. But before that, okay, we need to test for something. Okay, it's called test for stationary test. Okay. So this was your step. Okay, 3, or we call them as error or residual or noise. Okay. Step 4 is check for stationarity. Okay, so we say stationary test. Now, what does that mean? It means, okay, if you remove your trend, noise, everything, then data should be stationary. Now, when we are doing our linear regression, okay, or so there also we assume that data is stationary. Okay, stationary means the data is influenced by no other parameters. Here you see data is influenced by trend, seasonality, things like that, right? Now, if I remove all these things, if I remove trend, if I remove, seasonality, then data should not be influenced by other factor. See, if data is influenced by some external factor, then it is very difficult to predict, isn't it? Right? Because if it is influenced by other factors which you are not aware of, which you do not know, then how can you capture it in your algorithm? So we need to perform stationary test, and there are 2-3 ways of doing it. So what does stationary means? It's stationary means, okay, the standard properties, okay, do not change over time by a very large value. Okay, so stationary means, okay, um a time series is said to be stationary. Okay, and so this is important. Okay, so to make time series analysis, the data, okay, or your time series, okay, that we created TS, okay, that should be stationary. Should be stationary. What does stationary mean? Said to be stationary if its statistical properties like your mean, okay, variance, okay, your autocorrelation, does not change by a large value. Doesn't change by a large value, over a period of time. Okay, that means, okay, little bit change will be there. I mean, it cannot be exactly the same, but it should not change by a large value. Okay, so we perform various steps. Okay, so you have a test like Dickey-Fuller test. We call them as so types of tests are like we call them as augmented Dickey-Fuller test, ADH. Okay, test. Then you have um, Kwiatkowski, Kwiatkowski, Phillips. Okay, and Schmidt, 3 scientists name. Okay, and in fact, there's one more here, Shane. So you have KPSS. Okay, test. Then you have Phillips Perrin. So we call them as PP test. Okay, so you can use any of this. We'll use one. Okay, Dickey-Fuller ADH test is okay, is popular one. So we discussed about test, right? So what do you start with the test? What is the first thing that we discuss, we do when we talk about test? Okay, so to perform any test, we have null hypothesis and alternate hypothesis, right? Alternate hypothesis. We did this, right? So your null hypothesis is the time series is not stationary. Obviously, opposite of this is time series is stationary. So we need to prove null hypothesis is incorrect. Okay, we need to prove that null hypothesis is incorrect. Okay, and if you're able to show that null hypothesis is incorrect, that means opposite of that is, obviously it means, okay, the data is, okay. So how do we, when do we accept or when do we reject null hypothesis? When p value is more than 0.05, correct? If p value is more than 0.05, we reject null hypothesis. So when we perform this, we should look at the p-value, and p-value should be more than 0.05. That's when we reject, right?
Yes.
And I think in the book you have all the three tests, okay? But now we'll do only one, and then we will move to our prediction, okay? So if the data is stationary, we will move to prediction. So, okay. So I'm going to say from stats model, okay, dot TSA dot stat tools, third one, okay, import AD Fuller test, okay, and then let's say we call it as result. So result equal to AD Fuller, right? And we will pass our data. So our data is TS log, right? So now we will, no, data is not TS log. We created TS log to study that. Data could be your, I did not put, right? But yeah, I can say here, air passengers, right? And what is the column name here? This is without the log version, right? TS log is with log version. Okay. Okay. Now you want to print. Okay. So we'll print. Okay. So ADF test, right? So print um print ADF stats /n dot result. Okay, so this should give us the result. So see this, these are your values. Okay, Now, this is, okay, so instead of this, okay, I will put here, okay, your one is, this is your p value, okay, and these are your critical regions, 1% critical region, 5% critical region. Okay, so what I'll do is I will say here, okay, result of 0. Okay, and if you want to know the p value, print p value equal to result of 1. Okay, okay, and this entire thing is 4, right? And this is the 5%, right? Looking at 95% critical region, right? So this is your 5% critical region, right? So we need to know this. Okay, so your p of 0, okay, this should be, okay, see if this is greater than this, okay, so multiple thing, okay, to reject null hypothesis. See, before conducting any test, you need to have your aim hypothesis, right? To reject null hypothesis, your result of 0, okay, should be less than 5% critical region value, and p should be greater than 0.05. Okay, so you see here, you can directly see, right, that 5% is minus 2.88, and obviously this value is greater than this, and this is also greater, right? So our our uh, our uh, data is stationary. Okay, okay. So so now we have to run our model. So the most popular model, okay, that you will see here is called ARIMA model. Okay, ARIMA model stands for Autoregressive Integrative Moving Average. Okay, and so you see this p value. Okay, so yeah. So now the final step, run the model. So we are going to use ARIMA model. Okay, ARIMA stands for Auto, okay, regressive, auto-regressive, auto-regressive, moving, okay, I is for integrative, then you have moving average. Okay, so see what is moving average? There are many ways of predicting the times is kind of bigger. Moving average is, okay, you decide a period, time period, 3 months. Okay, for example, I'm just giving you a simple definition. So if I say, okay, moving average is, okay, okay, so here, okay, so this is basically your 3 models together, AR, I, and moving average. We'll start with moving average, yeah. So to talk about what each of these things means. So moving average, okay, so when you look at prediction, right? So see, if I want to predict what will, and this is again with respect to time series data, okay? I want to predict what will happen in December, for example. Okay, which And of course, we need to use past data to predict, correct? Now tell me, which will be more relevant? Your January data will be more relevant, or your, let's say, October data will be more relevant, or September data will be more relevant to predict December data? Because we have removed seasonality. See, we have removed seasonality, we have removed trend. So now the trend and seasonality is not part of it. Okay. So what we'll do is we will remove all these things. We will take the plain data, we will predict the plain data, and then for forecasting, we will add trend and seasonality. Seasonality, we know which month by how much. Trend, we know by how much it is increasing. We will add to the final prediction. So which will be more relevant? January will be more relevant, October will be more relevant. Obviously, October data will be more relevant. If you want to predict for tomorrow, your knowledge of today is more important than your knowledge of last month. Okay. So tomorrow is 29th. So what will you do on 29th? For example, if I ask you, okay, if I ask you on 1st of the month, what will you do on 29th? You will be 50% sure. Today, you will be probably 90% sure of what you will do tomorrow, right? So as we come closer to the period, okay, the shorter period prediction is more accurate. And this is what we will see when we actually plot the final prediction plot. So here moving average is the average that your prediction. So we'll say 3 months we'll use to predict. So if I have to predict for December, I will take November, October, and September data. September, October, November, you take this 3 months data, take the average of these 3 months, and you say this is what we expect in December, right? So the average is moving, okay? It's moving based on the time period that you are trying to predict. If you have to predict for August, then I will use May, June, July data. Okay, so the number of months is fixed. You can take 3 or 4 or whatever, and sometimes we give weighted also. Okay, moving average means simple average, but you can give weight also. So you can say that out of 3 months, first month will have weight 1, second month will have weight 2, third month will have weight 3. That means you're giving more weights to third month. So so you can choose which month. Okay, which month to give more importance, right? So that's called moving average. Okay, so moving average uses your information from past months, okay, to predict your future. Okay, and this gives us in the ARIMA model, this give you a parameter Q. Okay, parameter Q represents moving average value. Okay, so because we are talking about three things, right? So when the model we construct should have these values, isn't it? Okay, then we talk about I. I is integrative. Okay, what is integrative means? Okay, why do we use this here? So see, this component, okay, will help the series, okay, using what you call as differencing. Okay, so differencing, okay, that's why I say integrative. Okay, so is an operation where an observation is subtracted from the previous step. Okay, so basically when we say that the trend and seasonality is removed, this is what will remove the seasonality and trend. It removes, okay, now if I have to, so this month output is 100, let's say. Okay, now out of, you will not take exactly 100 as input in the next month. You will remove the trend, you will remove the seasonality, and you will say, okay, so the stationary data would have had only 50. Okay, so you will go with 50. Okay, so this is the job of I. Okay, and we don't know these values. Okay, how much these values will be. So we'll have to, again, we have to what you call as run the model again and again and again and again to find the perfect values for these parameters. Okay, so this is your integrative. Okay, integrative, okay, integrative by removing trend and seasonality component from previous period. Okay, but I'm using period because if in this case is monthly data, so you'll talk about monthly period. Okay, if it is quarterly, you will use quarterly, right? So it will remove the data. Okay, so this is your I part. Now what is AR part? Okay, auto regressive. This is the actual model. Okay, now okay, so here we'll be using parameter P. Okay, okay, so okay, this is like your regression kind of thing. Okay, so predicts the current value. Okay, so when you create this equation, okay, the ARIMA model equation, okay, ARIMA model will have three parameters that we need to talk about. Okay, which are those three parameters? We have three parameters like your P, okay, your D, and your Q. Okay. Now, in the book also, I've given detailed explanation about these things, and we also talk about uh, which parameters to in equation how does P, D, Q, or A, R, I, or M, A works. Okay, so you can read about it. But as I said, okay, the ARIMA AR is to predict the value. But to predict, you have to remove the past data, the trend and seasonality, that I will take care of it. Now, if you do not have any seasonality or trend in your data, some products may not have that. Then you can directly use ARMA. Okay. If there's a lot of seasonality, then you have SARIMA model, seasonality, ARIMA model. So again, there are various versions of ARIMA, okay, which probably we can discuss later once we are done with this so that we see how it works. So here you see you have auto-regressive component, which is P. You have integrative or differencing component, D, I, which stands for I, D. And then you have average, moving average, okay. Now, how do we find the value of these, right? How do we find the value of these? So to perform a value of these, we create what is called as ACF. Okay. Um, so okay. Or you can directly run and get the different values. Okay, so what I'll do is I will try to show you the um, um, the first we look at P and Q value. Okay, so we have graphs like we spoke about AIC, BIC before, remember? Okay, but we didn't we didn't focus much on those values then. Okay, if you remember when we created our multiple regression using the stat model, okay, there was a component called AIC, BIC. Okay, now here your AIC, okay, AIC is called as Akakai's information criterion. Okay, AIC. Okay, AIC curve. Okay, so this will help us to, okay, and we will run this. Okay, okay, so this is helps to find optimal, okay, your P, D, Q values. Okay, you have another method called as BIC. Okay, which stands for Bayesian. Bayesian basically means your probability, right? So Bayesian information criterion. Okay, BIC. Another way. Okay, alternative to BIC. Okay. So let's do that. Okay. So what I'll do now, okay, we'll create one plot here. Okay. So we call this as ACF. Okay. So from stats model, okay, dot graphics dot TSA plots. Okay. And from here I will import your plot ACF and plot PACF. Okay, and now let's draw this. So plot ACF, and I'm going to say here air passenger, right? ACF air passengers. Okay, and we will remove the difference part here. So okay, dot not required because here we don't have any NA values, right? But this will help you if your data set has, null values. Okay, and then we can say plot PACF. Okay, I can use plt.show and plt.show here. Okay, let's run and see this graph. In fact, okay, what I'll do is, okay, let me stop this. Let me plot this together. Okay, meanwhile, let it come up and we'll see how to read this graph. Okay, so you have autocorrelation and partial correlation. ACF is autocorrelation. Okay, so this is your autocorrelation. So you see this autocorrelation graph. Okay, now this will help us to find Q. Okay, okay. Partial correlation will help us to find Q. Q is your moving average. Okay, so how do we look at here is you look at the exponential decrease. You see there's an exponential decrease here. Okay, so you have a value like you have like 0, 5, 10, right? 15, 25. Okay, now okay, so look at this data here. At 0, you're able to see this line, right? At 0, you see this line is maximum, right? It's going from 0 to 1. But suddenly what happened? It decreased at 1. So this is 1, 2, 3, 4, 5. Okay. So that's what you 5, 10, right? So 1, 2, 3, 4, 5. So the decrease, as you see, the drastic decrease here is at 1, right? So the Q value is probably 1 here. Okay, so Q value is probably 1. So let's go back to our notes and we'll update it. Okay, so Q is moving average, right? So to find Q, we look at the auto correlation graph and see where the value, okay, where there is a drastic change. So in this case, drastic change. So here it's at 1, right? So your Q is equal to 1. So looking at autocorrelation graph and look for the drastic change. So here the graph says that Q value should be approximately 1. Okay, or you can take 2, right? And we should actually try with 1 or 2 values, right? We cannot directly say, okay? So now drastic change, okay, if you remember, there was 2, it became negative, right? So now how do you justify whether, you call from +1 to 0.25 as drastic change, or 0.1 or 1 to minus 0.25, right? So you can try with 1 or even 2 in this case, right? Or 2 as at 2, okay, it goes to negative, right? So it could be 2 as well. I can take 2 also here. Okay. Now, if you look at p value, okay, so you have AR, right? Auto regressive. Now, to find your auto regressive component p, okay, we also look at, okay, your drop, okay, in partial correlation plot, okay, PACF, okay, to find p, okay. So this is AR, right? Component, and this is your MA component. Same thing, okay, sharp drop in PACF graph, okay, that is your partial auto correlation graph. So let's go and see. Okay, I'm going to say new share. I'm going to share the graph, 1 second. And I think this is the partial. Okay, something similar you notice at 1, right, or 2. This is partial correlation. Okay, this is also something similar. So same, just like your other thing here also. Okay, so here it's 1. Okay, so p equal to 1 or 2 also you can take, right? So yeah, then yes, but what about I? Okay, so I, okay, you have to try with multiple values. You have to try with multiple values. I is your D value, right? So for D, try with multiple values. So, okay. Now here, how do we do test and train data? Okay, so now let's say, okay, we have taken 1, 1, or let's say 1. Okay. initially we will take as 1, let's say. Now we have taken 1, 1, 1. How do we know 1, 1, 1 is the right data? How do we see in your regression and classification, we have divided data into train set and test set, right? So train set and test set, we say that, okay, your looking at the validation error, okay, we know how good we are, right? How good is our model, right? How good we are with our prediction. But here, what do you do? Here, what do we do? Okay. So here, okay, we will do it tomorrow. I'll show you how to make prediction. But here, what we do is, so let's say you have, we talk about different data set, right? So let's say here it's monthly and we have taken time period as 12 months, correct? So now let's say you have data from 49, 1949, 50, right? 51, 52, 53, 54, and 55. Let's say you have data from 49 to 55. So obviously, using this data, we will predict for 56, right? But what we will do is, okay, we will predict it. We'll take, let's say, we will take data from 49 to 52, and we will predict for 53. Again, you will take data from 50 to 53, and you predict for 54. So, because 56 data, you don't have it, right? So even if I predict junk, okay, I will not know whether the output is junk or actually good prediction. So you will hide this 12 months. You will use data up to 54 to predict for 55. You will hide data up to, you will take data up to 53 to predict 54. And since you have data for 53 and 54 and 55, you can compare how well your model has predicted. Okay, so before you actually predict for 56, we need to predict it for 53 and compare the values. We are taking 111. Is 111 a right parameter? Okay, no, the error is high. Then you'll take with 121, then 221, because our P and Q ranges from 1 to 2, right? So it cannot be 3. Okay, so it is either 1 or 2. So your extreme left and right, P and Q will be 1 1 or 2 2 or 1 2 or 2 1, right? And I you can keep, or your this D you can keep changing 1 2 3 4 and C, right? So again, you will have various combinations, at least 8 to 10 combinations you will end up creating, right? And then you look at out of these 8 to 10 combinations, which is giving better prediction for 53, 54, and 55. Whichever combination gives you better prediction for 53, 54, 55, that will be your final PQ D value. PDQ, PQD, whatever you call it, okay? So final PDQ value will be one that is giving you least error with, and how to find error? Of course, these are numbers. So you have variance and standard deviation, whichever has least standard deviation or your root mean square, right? Here, you can directly find standard deviation, right? Or root mean square is same thing, right? You can find out the minimum variance, and the one that gives you minimum variance, that is the right parameter. All right, so we'll stop here. Tomorrow we'll talk about how to make prediction. Make sense?
Yes.
Okay. And tomorrow we will end our machine learning algorithms. Then we'll get to visualization.
Yes.
Chalo. Bye.
Bye bye.
Okay, so now we will run this model. Okay, so we have decided to use PQD as 111. Okay, and we will run this model. To run this model, we need to import, right? So we need to import the ARIMA model, right? So I'm going to say from stats models dot TSA dot ARIMA dot model. Import ARIMA. We'll create the model. So model equal to ARIMA, and you have the column here. Okay, so we'll use air passengers. Okay, this is the data and the order PQD order equal to 1, 1, 1. Okay, so once you run the model, then we perform fit. So model equal to the model we have already done, right? So now we will fit the model, right? So I'm going to say a result or output equal to model dot fit, right? And now let's predict the values here. So I'm going to say plt dot plot. Okay, and here we'll plot our data. Okay, and now the prediction part. Okay, so here I'm going to say plt dot plot our result dot fitted values. Okay, so this is the prediction part. Okay, and now if you want to print the data in okay, so we'll say plt dot show, and also if you want to see the data, we'll say summary. Okay, so print ARIMA model summary, and you go ahead and say print the result dot summary. Okay, that is it. So now let's run and see what happens. Okay, so this is the original plot that we saw yesterday. Trend. This is the first, first one is of course the original data. The first graph that you see is the trend, then seasonality, and the error residual part. Okay, so these are your partial autocorrelation and autocorrelation, which are important to get PQD value. Okay, now this is the data without your seasonality part. Okay, this is what ARIMA model will give you. Okay. Summary is a function. Okay. Let's go and see the summary again. So see, these are the results. Okay, you look at AIC, BIC, right? So which is okay. I mean, our model is done well. Okay, and these are your ARIMA data coefficient. Okay, okay. Now see, so the plot that we have seen here, okay, talks about the fitted values, isn't it? Okay. Now, if you want to see whether this model is correct or not, right? So we need to keep changing the order value, right? So what I'll do now, I will run it second time, okay? And this time probably I'll use, let's say, 414, let's say. Okay. And then we'll compare the result from first two data. Okay, so this is from 111 and this is from your, so these are the errors, right? You see, as you go away from, so as you go away, your error will obviously increase, right? But this orange part is within this blue part, right? So that's how we know that it is doing well, okay? Now, um, so this is how you can create or predict your ARIMA model, right? But our next, um, next, this is to fit the model, right? Our model has been fit. Now the next part and the last part of our discussion is prediction. Prediction using ARIMA model. Okay, so to create, to predict, we will create one new column, okay, and there we will add prediction value, right? So I'm going to use air passenger, and here I'm going to call this as air passenger, I'll say forecasted. Okay, so this is going to be result dot predict, right? And in prediction, we will give the period. Okay. Okay, so start and end. So it is all monthly, right? So start from which month you want to start. So if I say, let's say from 49 to 50 is that data, right? No, data is from 60, from 49 to 60. Now we will try to predict from 10-year period. So I'm going to say here, start is 120 and I will say end equal to 120 plus 10, 240, right? Or let's say we'll predict for 6 more months. So 246. Okay. So this air passenger forecasted column will have the prediction value. Okay. And if you want, of course, to plot the forecasted and the passenger data, we can create another plot. So I'm going to say here, air passengers, okay, and you have, let's say, first we'll plot the passengers. So I'm going to take this. Okay. So I'm going to say passengers dot comma forecasted. Okay. And dot plot. Okay. Plot. And that's it. Okay. And I'll say plt dot show. So this should show us the predicted value. You can calculate using whatever statistics you want. You can calculate the forecasted and the actual values. And this will, okay, now let's look at this. So see, this is our actual value. And from 145 to 146, this is our predicted value. Okay. Now we will use one more technique. Okay. Where we will add seasonality also to it. Okay. So this is your model prediction using ARIMA model. Now we'll predict using SARIMAX model. Okay, so let's see how it happens. So I'm going to say import your stats models dot API as SM. Okay, now I'm going to create model, second model, and we'll say SM dot TSA dot, okay, stat space dot SARIMAX. Okay, so this is how we call SARIMAX. Now here I'm going to call the data, which is air passengers. Okay, air passengers, and then we'll give the order to it. Okay, so order equal to, let me put here 7, 1, 7, right? Now these numbers, as I said, you have to play with these numbers. Okay, you will not know these numbers. Okay, you have to play these numbers. And we also give the seasonality order, and seasonality order we are saying is, it's okay, 1 for every 12 months. Okay, and then of course we'll say results equal to your model dot fit, right? And now we will have prediction, right? So air passenger, and here I'm going to say forecast SARI max. Forecast SARI max equal to result dot predict, right? And we can give, we'll use same data. Okay, predict start 120 to 246. Okay, now we will plot our graph. Okay, and here instead of forecasted, we use forecast SARI max. Now let's see what happens. Okay. Okay, so this is a prediction from ARIMA. Okay. Okay. Now Oh, I didn't use plot dot show. Run it again. So this is the ARIMA model prediction. Okay, now this is Sarimax. Okay, so see, this is predicting almost on par with our actual value. So there is very close prediction, right? Because we have taken trend and seasonality also into consideration. Okay, does that make sense? So this is how your your model prediction for time series is different than a regression model. Okay, so with that we complete our time series analysis. Okay, so time series analysis, we need to separate trend, seasonality, and then make the prediction based on that. Okay, all right. Okay, now even in ARIMA model, if you want to see the prediction without removing the trend and seasonality, okay, so you will remove this diff. Okay, this was to remove the trend end, right? So if you remove this diff, and this is from your this was to get uh, the error value, right? So what I'll do here, okay, I'll just remove this part. Okay, if I remove it, okay, that means I'm not differentiating this plot. Okay, now when you make prediction, so we'll remove this autocorrelation correlation part. Okay, so this is the fitted value. I did not use diff, so it's taking entire data. Okay, so you cannot see the error part. Okay, if you wanted to see just the error part, you put the diff. Now the prediction here is going to be, better here. Now you see, this is your prediction part. So this is your ARIMA prediction. And since anyways, in the other one, we have used the entire data, right? So we're not looking at just the error part. Okay, so this is the actual prediction for the next period. All right. So with that, we complete our time series also. We'll stop here for today. And next week when we meet, we will get down to data visualization. Okay, so we will look at some statistical components. Okay, and then we'll we will look at different ways to plot in Python, and also we will briefly touch upon Tableau and Power BI as well. Okay, so we'll end it here. We'll see you. Yeah.
Sir, actually,
Yes.
I have to show you some. Actually, I have done project, तो I have to show you. मतलब मैंने कितना किया और मतलब उसमें मेरे को कुछ डिफिकल्टी आ रही है, तो
बिल्कुल
मैं चाहता हूँ अभी
बिल्कुल
आपको दिखाना. प्लीज मतलब 2 मिनट आप कनेक्ट
हाँ
हैं.
हाँ हाँ
मैं
बिल्कुल.
मैं लैपटॉप से
मैं
कनेक्ट हो रहा हूँ.
शेयर, हाँ ठीक है, मैं स्टॉप कर दिया एंड प्लीज गो ahead. या अंकित एक काम करता हूँ अंकित,
Yes, sir.
मैं
Yes, sir.
ये इसको एंड करके एंड देन विल स्टार्ट अगेन. ओके, सेम लिंक,
Okay.
ज्वाइन बैक अगेन.
Okay. Okay. Okay.